at an angle theta from the ground. How do it will move? It will move in a parabolic path. It's going to move in a parabolic path. I think it's a little bit. This is a tower. So how it will move? It will going to move in a parabolic path, and it will strike the tower. Possible. It's not that always you are going to project the ball from the tower. So here we are projecting from the ground. The ball will go and will strike the tower somewhere here. Then how to write all the some possible equations? Again, what is the condition? And the ball is ascending. This is the highest point. U cos theta will be Vy. What should happen to horizontal component? Should remain constant. Vertical component will change. And how the gravity? The gravity is acting in this direction. Now, what is the initial? This is the initial point. And this is the final, where it will strike. And this is the time of flight. At t equals 0, we have projected. Can we write any equations? Again, the conditions are same. Applying equations of motion along x, along y. Along x-axis, there's no force acting. Along y-axis, the weight will act. And because of weight and the initial velocity projected, it's going to move in a parabolic path and it will go and strike the tower, which is at height h. These are conditions given for us. How to write down the equations? Again, applying the equations of motion along x, along y. Along x-axis, what type of motion is going to describe? Uniform velocity motion. So the equations will be, it will go and strike the tower say at a distance x. So what is x is equal to u cos theta? Let me write directly here. I'm applying equations of motion only. It is like this, the formula. Let me rewrite here. Ux t plus x t square. What is ux? U cos theta, time of flight 0, t square by 2. What is u? Horizontal speed. If they give any value, we can substitute, we'll get that one. So at what distance on the tower it will strike it. Then if they give x u cos, we'll calculate the time. Then if they give this h, we can write the equations. Now look at this one. This is the initial point. This is the final point. How is the displacement? The displacement is measured in this direction, vertical displacement. And how the vertical displacement is measured in the direction of initial velocity. So therefore, h should be positive. Agreed. So with the help of this, we'll calculate the time taken. So the time taken we can calculate plus h u sin theta t y minus sign, y positive sign. The displacement is measured in the direction of initial velocity. So therefore h positive. How g is acting? The g is acting opposite to initial velocity u sin theta. So therefore this has to be negative. Let's, I think we have all the data here. U theta h is given, g 2 we know. So from here we'll get the time. Substitute the value of t, we'll get x. Now, sir, how you calculate Vy? Again, we'll apply the equations of motion. Vy whole square uy square. Now look at this. So y minus Vy. This Vy is directed opposite to u sine theta. G is directed opposite to u sine theta, negative. Whereas H is in the direction of u sine theta. Applying equations of motion with due regard to the conventions like signs is what the projectile motion. Okay. Solving this, again, we'll get the required thing. So Vy square minus u sine theta whole square minus 2gh. Then what is the total speed given by Vx square plus Vy square? Vx will remain constant. The horizontal component has to be constant. Why horizontal component should be constant? And because projectile motion, there is no acceleration along x-axis. Are you looking at this? The horizontal velocity has to remain constant. So we can project a projectile from the ground so that it will go and strike the some point on a tower.